Hello, hello, hello. Hope everyone's doing well. I'm just going to jump right into it. Today we're doing section 1.1, lines in a plane. Almost everything in this section should be review. Just have to make sure the turtles are okay. Okay, so everything in this section should be review, and if it's not, it should at least look familiar, like if you don't remember how to do it, but at least it looks familiar. So we're just going to go ahead and jump right into it before my computer starts to overheat and not allow me to write anymore. So, for objectives for this lesson today, we're going to look at how do you find the slope of lines. The slope. Okay, so how do you find the slope of lines? We should know how to do that, but again, if you don't remember, here's your chance to review. And then we're going to review how to write linear equations given points on the line and the slope. Okay, so if I'm given a point and I'm given a slope, how do I write the equation? Then we're going to use slope-intercept forms of linear equations to sketch the line. So we're going to review how to graph that straight line. Okay, and then we're going to use slope to identify parallel. Oh, it's already starting to overheat. Goody. Parallel and perpendicular lines. And I do want to show you, I don't want to have to write perpendicular like 50,000 times, whether or not it's on this tablet. So I just want to review with you the sign for perpendicular, which is an upside down capital T. So that means perpendicular. So if you see that written, that's just all it means, perpendicular lines. Okay, so let's move down and talk about slope. Okay, so this should be fairly familiar. The slope of the line is how steep the line is increasing or decreasing. Okay, and if you're given 2 points, this is the equation we're looking at. I don't know why I circled that one first. That's funny. So these two, either way, notice that the idea is the same. This is y2 minus y1 over x2 minus x1. This one's y1 minus y2. So just the ones and twos are switched. And that's fine. It doesn't matter. As long as the twos are lined up and the ones are lined up. So you can't do like y2 minus y1 and then x1 minus x2. Okay, so the twos and the ones have to be lined up. But, and the y has to be on top. But other than that, the order doesn't necessarily matter. So just one quick review problem, and I'm going to scroll down so we can see it all. Okay, so find the slope of the line. Okay, so my equation is m equals y2. So my second y is 1, so 1 minus, and my first y, y1, is 0, over, and then x2 is my 3, minus, it's always minus, x1 is negative 2. So I get that double negative there. So 1 minus 0 is 1, and then because of this double negative, it changes to a plus, right? So I get 1 over 5. And there's my slope. Okay, so go ahead and hit pause on this video. I want you to do B, C, and the extra example just to practice. And then whenever you're ready, go ahead and hit play, and I'll see you in a second. Okay, so hopefully you had a chance to do these. Look these over real quick. A couple things that I want to point out as we go through. You should have gotten 0 for B, right? Anytime you have 0 on the top of a fraction, you're going to get 0. And so because of that, a very special type of line has a slope of 0, and that special type of line is a horizontal line. Okay, so horizontal lines are the only line that has a slope of 0. What happened to my L? So horizontal lines, it's like you almost have to watch this at double the pace because I'm not able to write any faster. I have a slope holy moly, come on now, of 0. So anytime you get 0 on the top of that fraction and you get 0 as your slope, that is a horizontal line, no matter what. In this case, it's a horizontal line that passes through 2, and I know that because that's the common number that's on both. Okay, and then for C, you should have gotten -5, so double check that. And then for that extra example, I got -3/0. Well, now 0 is on the bottom of the fraction. Hopefully you remember you're not allowed to divide by 0. You can't divide by 0. So I get undefined. And the type of lines that are undefined or have an undefined slope are vertical lines. So vertical lines. Vertical lines have undefined slope. So that's really important that we know the difference of when slope is 0 and when slope is undefined. I'm just going to start writing faster and see if it works. Okay, so vertical lines have undefined slope. So just a quick little reminder here for us about slope. All good? Okay, so let's go ahead and clear this. We're going to move on. I'm going a little faster than I feel like I normally would, only because this should all be review, hopefully. Okay, so a line with a positive slope. If my line is increasing from left to right, increasing, there we go. So a line with positive slope increases or rises, you can write increases if you want, but we say rises from left to right. So if my slope is positive, like it was in part A, in question A, then it's a positive slope. A line with a negative slope falls from left to right, or you can write decreases, that's fine too. But then the line, it falls from left to right. And then a line with slope 0, we just talked about, is horizontal. And then horizontal. And then a line with an undefined slope is vertical. So again, that's just a little summary of what we kind of just went over. Okay, so then we're going to move on to point slope form. I think we can find slope. I think we're feeling okay about that. So let's move on to point slope form. Point slope form is very easy to remember because it has a point and a slope in the name. So in order to use point slope form, you have to have a point and a slope. Okay? So if you're not given a point and slope, you can't use this form. So hopefully you're like, okay, that makes sense, right? It's in the name. So if I have m is always my slope, right? If I know what the slope is, and I know that it contains this point, x1, y1, then this is my point slope form, right? Where x1 is here, and then y1 comes there. X and Y in this case stay X and Y. They do not change. Okay, so the only thing that's changing is your Y1, your X1, and your M. Okay, everything else is gonna stay the same. So let's look at an example here, and I think you guys will be like, oh yeah, I remember this. All right, so let's look at example 2. And example 2 says, find an equation of the line that passes through the point 1, -2, and has a slope of 3. So here's my point slope form. I'm just going to write it y minus y1 equals m times x minus x1. So I just copied that from the previous page. It's no big deal. Okay, so this tells me this is my x1. Remember, x and y don't actually change. Only the x1 and y1 change. And then this is y1. And then 3 is my slope, m. So I'm just going to plug in my values. So let's see here. We have y minus, well, my y1 is -2. I have a double negative there. That's okay. My m is 3, so 3. And then x minus, and then my x1 is 1. Okay, so I'm just going to start simplifying here. I have y plus 2 now equals, and I can distribute this 3. So 3 times x is 3x, and then 3 times -1 is -3. And then it says, then solve the equation for y. So we want to get the y by itself, so I'm going to subtract 2. Subtract 2. Oh boy. And I get y is equal to 3x minus 5. And that's it. There's my equation of the line that goes through the point 1, -2 and has a slope of 3. So I want you to try this extra example. Excuse me, go ahead and hit pause on the video. Give it a shot, and then whenever you feel ready, you can come back and check your work. Okay, so this one was a little bit not tricky, but you have to do 2 steps, right? Because the question is, do I know a point and a slope? And the answer is no, I don't. I only know 2 points. But then you have to ask yourself, can I find slope? So hopefully that was your first step, was to find your slope. So my slope here, I have -6 is my y2, minus -1 is my y1, over -1 is my x1, minus -2 is my x2. Lots of negatives going on, right? So this is really -6 plus 1, which is -5, over, and then this is really -1 plus 2, which is 1. And so we get a slope of -5. So now I do know a point and a slope. So now I'm able to use my point slope form. So y minus y1 equals m times, wow, x minus x1. Alrighty, there we go. Okay, and I can just start plugging things in, and then the question is, which point do I use? Because I have 2 points, right? And you can use whatever point you want. You can use this -2, 1, or -1, excuse me, or you can use this -1, -6. I don't care. I'm going to use this -2, -1 just because the numbers are smaller, but it literally doesn't matter. So I have y minus -1 equals, my m is -5, boy, times x minus x1, which is -2. So I'm going to go ahead and simplify. I have y plus 1 is equal to, the -5 times x is -5x. And then this is really plus 2, right? So -5 times +2 is -10. And then the last step, I want to get that y by itself. So I'm going to subtract 1, subtract 1. I don't normally write the minus 1, things like that. So I'll do that for the first couple lessons, and then we'll stop doing that. And then negative 10 minus 1 is negative 11. So there's the equation of the line that goes through those 2 points. So you have one more extra example here. So I want you to go ahead and try it. Notice that you're given the points. They're just on a graph. It's no big deal. It's going to be the exact same thing. So go ahead and hit pause on the video. Try the extra example B, and then we'll see you back here in a second. All right, for this is just like example A. I'm given 2 points, and I need to find slope. So slope, if you remember, is rise over run. So I have m equals, and then I'm just going to pick a random, I'm going to call this one x2 and y2, and then this one x1, y1. So if I use this one first, I have negative 1 minus 3 over, and then my x2 is 1 minus my x1 is negative 1. So this gets me negative 4 over 2, which is negative 2. So here my slope is negative 2. Well, that's great, because now to find the equation, I can use my point slope form because I know the slope. That's an M, sorry. I'm not going to go back and fix it. Okay. So I'm just going to plug in things. I'm going to use this negative 1, 3 just for fun. So y minus my y1 there is 3 equals m, which is negative 2, times x minus negative 1, because that's my x1 is negative 1. And then we solve. So y minus 3. I'm going to distribute this negative 2 to get me negative 2x. And then that's really a positive 1, so negative 2 times positive 1 is negative 2. And then we add 3 to the other side. So I get y equals negative 2x plus 1. That's it. Okay, so hopefully we're feeling good about it. Nice little review here. And we're going to move on to example 3. Oops, that's not what I want. So example 3 is all about Nike. You know, my home state there. So this says, during 2004, Nike's net sales were $12.25 billion. And in 2005, net sales were $13.74 billion. Write a linear equation given the net sales y in terms of the year x. So x is the year, y is the money. Then use the equation to predict the net sales for 2006. So what I'm going to do is I don't want to use 2004 as my year because that's just a pain and it's a big number, right? 2004. So I'm going to pick something easy. I'm going to let x equals 0. Come on now. Represent. Why do I pick hard words to write, right? Represent the year 2000. And that's kind of easy because, you know, the last digit in 2000 is a 0. So x equals 0. Okay, so then what that means is that 2006, let's say, for example, since I'm going to have to find that anyway. So that means that 2006, I can just use as x equals 6. Okay, so now I'm at the point where I can write points. So I can say, okay, in 2004, so x is 4, net sales were 12.25. And I'm just going to write 12.25. I already know it's billion, so I don't need to do anything special with it. Okay, and then I know in 2005, so 5, net sales were 13.74. So can I find slope? Yes. And once I know slope, can I write the equation? Also yes, right? So my slope, m equals, there we go, 13.74 is my y2, minus 12.25 is my y1, 12.25, all over 5 minus 4, which is just 1. Okay, so I end up getting 1.49 billion. Holy moly, right? So every year, Nike's sales go theoretically, right, go up almost a $1.5 billion. There's so much money. What would we do if we had all that money, right? So that's my slope. Now I can write the equation. It's no problem. So y, I'm just going to go straight into it. I'm going to use this 12.25, I think. So y minus 12.25 equals, and then my m I know is 1.49 times x minus 4. And we just do our thing here and solve. So y minus 12.25 and I'm going to distribute the 1.49, so 1.49 x, and then 1x, and then 1.49 times negative 4 is negative 5.96. And you can confirm that on the calculator if you're really dying. Then the last thing, all we need to do is add this 12.25 to the other side so we have our linear equation. So I get 1.49x plus, and then negative 5.96 plus 12.25 is 6.29. And there is the equation. Woohoo! So that's the equation modeling Nike's net sales. Now I want to predict how much they're going to make in 2006, so I can just plug in 6. So y equals 1.49 times 6 plus 6.29. Okay, so 1.49 times 6, who knows, plus 6.29, and I get 15.23 billion dollars. Can you imagine? $1 billion. Crazy. I could do so much with $15.23 billion. All good. If not, rewatch the video or reach out if you're have any questions on what I did or things like that. Just feel free to reach out and we'll get you taken care of. And we're going to move on now again to looking at sketching the graph. Okay, so slope-intercept form is what we were just doing. We were writing things in slope-intercept form, which is my y equals mx plus b, right? And then, so the slope is always your m, and then the y-intercept, where you start on the y-axis, is always your b. So the quickest way to graph is, if it's in this form, is to start with b, put a point on the y-intercept, or the y-axis, excuse me, at point b, and then just plot your rise over run with your slope. So the easiest way to remember this name is because it says slope intercept. So you need to know the slope and you need to know the intercept, the y-intercept. So we're going to look here, and I'm going to do 2, and then you guys are going to be doing 4. Okay, so let's just get on in it. Okay, so this one, determine the slope and y-intercept of each linear equation if possible, and then graph the line. Okay, so here I don't have, my equation is not in slope-intercept form because I want it to be y equals something. So I need the y by itself. I'm going to subtract my x, and I get y is equal to negative x plus 2. Okay, so now it's in slope-intercept form. So now I can tell you what my slope is. It's always the number in front of x. Well, the number in front of x in this case is negative 1. And then my b is always my y-intercept. You always need to write your y-intercept as a point. Okay, so it's always going to be 0, comma, and then in this case, it's 2. And then now I want to graph the line. So 0, 2 is a point. And then this is rise over run. So I go down 1, over 1. Right? Think of negative 1 as a fraction. So if I write negative 1 as a fraction, I can write negative 1 over 1. So my rise is down 1, and then my run is positive 1, and so on. You also could write this as 1 over negative 1. So that would be going up 1, but then your run is to the left. So that's why you can go in both directions. I'm just plotting a ton of points because I know I'm not gonna be able to draw this like at all. You guys can draw a better one. Yeah, it's just a weird angle for me. Better. Okay, and that's it. I would use a ruler or a straight edge if you have it. I don't think that I have the option to do that. Okay, this one, notice that there's no x. So this is really like y is equal to 0 x plus 2, right? Because 0x is just 0. So this is what tells me that my slope is 0. And then my y-intercept is the point, it's always 0, oh gosh, sorry, 0, comma 2. Remember what happens when you have a slope of 0? It is a horizontal line, okay? So that means that here's my y-intercept, and then it's just going to be a horizontal line at 2. So hopefully that makes sense when we reviewed our slope. Okay, go ahead and give these next 4 a try. You want to tell me what the slope is, tell me what the y-intercept is, and graph it. And then when you're done or you're feeling ready, you just go ahead and hit play, and then we can go over it. So I'll see you in a second. Okay, so check your work here for problems C and D. You should have solved for y here, which would have gotten you a fraction, and that's totally okay. I would normally leave it as a fraction, just because then it's easier to graph as a slope. So you should have gotten a slope of 2 over 3, and then a y-intercept of 0, -6. So I started at -6, I went up 2 over 3, or down 2 to the left 3. Over here I solved for y, and I got -2x plus 3, which tells me my slope is -2, and my y-intercept is 3. So I started at 3, and I went down 2 over 1, down 2 over 1, and so on and so forth. So if you haven't done E and F yet, go ahead. Otherwise, let's go over them. Okay, so these two were a little bit more tricky. E was just just like B up above, where I solve for y. Because there's no x, I get that the slope is 0. My y-intercept is -7 over 3, which is just slightly smaller than -2. So that's where I drew it here. Right, -2 would be 6 over 3, -6 over 3. It's just one more third down from that. And then F, because I only have an X value, I don't have a Y value, that tells me that this is a vertical line. Well, a vertical line is not going to have a Y-intercept. Wherever that vertical line is, it's not crossing the Y-axis at all. So the slope is undefined and there's no Y-intercept. So all I know is that it's crossing at 14 over 5, which is just under 3, right? Is 15 over 5 would be 3. So it's just this vertical line. That was a subpar vertical line. Hopefully you did better. So vertical line at 14 over 5. So again, hopefully this is making sense. A nice little review. If not, please reach out. Let me know. And we're just going to keep going. Okay, so just a summary, I don't need my mask on, sorry. Just a summary of the different types of equations that we're going to see. So general form is sometimes called standard form, and that's just when the x and y are on the same side of the equal sign. So I have ax plus by equals c, where a, b, and c are all numbers. So this could look like 2x minus 7y equals 10 or something like that. Okay, I'm just making up random numbers. Okay, a vertical line is always going to be in the form of x equals a number. So like x equals 4 or something like that, right? And that's going to be a vertical line at 4. Horizontal line is always going to be y equals a number. So again, for example, it could be y equals -3. And that's going to be a horizontal line at -3. Slope intercept form. Remember, the name helps a lot. Slope and intercept. I need a slope and the intercept. So this is going to be y equals mx plus b. So that's when the equation is solved for y. Let's make that a plus. There we go. So an example of this could be like y is equal to, making up numbers, 2x minus 4. Something like that. And then point slope form requires that you know a point and a slope. So I would do my y minus y1 equals m times x minus x1. And then that's kind of when you have this, and I'm not going to write an example with it, but once you have this, you still want to end up writing it into point, slope intercept form once you're done. So point slope form is just kind of like that halfway mark that gets you from one point to the other. So that's a nice little summary of all of the different types of equations. So now we're going to look at example 5, and this is more of just like a make an observation problem. So here it says I'm given the graph of two lines. One of the lines is negative x minus 1, so that's up here. And the other line is negative 10x minus 1, which is here. Why do the graphs appear to be the same even though the slopes are very clearly different, right? One slope is negative 1, the other slope is negative 10. So why is it that they look exactly the same? And if you look really closely, you'll see that the scales on these graphs are totally different. So here my x-axis is scaled by 5s. Here my x-axis is scaled by 1s. So just noticing the difference that something like that can make. Okay, so just the answer here, just to answer the question why, so we can say the x scales are different. So it makes a really big difference. These two graphs look exactly the same, but you have to notice that the scales are off. All good? Sweet. Okay. Moving on. We're cruising today. Okay. Parallel lines. We're going to talk about parallel lines real quick. Nice little reminder, hopefully. Parallel lines are two lines that have the same slope. Okay, so they are only parallel if their slopes are the same. If their slopes are not equal, they are not parallel. Okay, if you have two vertical lines, obviously those are going to be parallel, right? And even and then two horizontal lines as well, but those have the same slope, right? Both of those have a slope of 0. Both of these guys have a slope of undefined. So either way, their slopes are the same. So let's look here at example 6. Just a quick look here. Find the slope-intercept form of the equation of the line that passes through the point 2, -1 and is parallel to this guy. Well, if it's parallel to 2x minus 3y equals 5, then we know that the slopes are the same, but I don't know what the slope of this is, so I have to figure it out. So I can find the slope by solving for y. So I'm going to subtract this 2x. Right, so I get negative 3y is equal to negative 2x plus 5. Okay, so, and then I'm going to divide by negative 3. My pen is getting real testy with me now. And when I divide by negative 3, I need to divide all these pieces by negative 3. So I get y is equal to negative 2 over negative 3. That's going to give me positive. And then this is minus 5 over 3. Okay, so I know that, oh, I forgot my x. Thank you. So this tells me that my slope is 2 over 3. All good? Now that I know my slope and I also know a point, I can use my point slope form. Y minus y1 equals m times x minus x1. And just start plugging in values. So y minus -1 is equal to, my m is 2/3, and then x minus 2. So I have y plus 1 is equal to, distribute that 2/3, and then 2/3 times -2 is -4. 4/3. Subtract 1, subtract 1, and I get y is equal to 2/3. Real slow moving with the pen, sorry, x minus, now we have to think about this for a second, we're going to do some mental math, right? 1 is equal to the same thing as 3/3. And I picked 3 because that's the denominator here. So I have -4/3 minus 3/3, which gives me -7/3. And that is the equation of the line that is parallel to 2x minus 3y equals 5 and goes through the point 2, -1. Hopefully we're all good. We can move on to perpendicular lines. Okay, so now we're going to look at perpendicular lines. So two lines are perpendicular if their slopes are negative reciprocals. You'll probably hear me say opposite reciprocals more often is what I will go with. But what we mean by that, like for example, so if I have a slope of 5/7, the opposite reciprocal of that would be -7/5. Oops. So the fraction flips, that's the reciprocal part, and then the opposite is, since this is positive, this is negative. Same thing if I had a slope that was like -8/11, then the opposite reciprocal of that would be +11/8. So hopefully that makes sense. Do keep in mind that like if you have a whole number, let's say like 5, right? So 5, if that's your slope, as a fraction, 5 is 5/1. So when I flip it, then I would have the 1/5. And then because this is positive, this would have to be negative. So those are just examples of like what opposite reciprocal slopes would look like here. So if we look at our problem, example 7, so it says find the slope-intercept form of the equation of the line that passes through the point 2, -1, and is perpendicular to this line. So same as up above, right? Same equation, but the only difference is, so I'm going to go ahead, we already wrote this in slope-intercept form in example 6, so I'm just going to go ahead and write it in slope-intercept form. So when we solved that equation for y, we got 2/3 x minus 5/3. So we did that up above in example 6. So the slope here, the slope is 2/3. So that means that my perpendicular slope, so I could draw my upside down t because I don't want to write perpendicular. So that tells me that my perpendicular slope is the opposite reciprocal. So I'll take the reciprocal, so it's 3/2, and then it's opposite, so it's now negative. So -3/2. So there's my slope. Now I can use point slope form. So I'm just going to go ahead and plug it in. So y minus my y1 is -1 equals my m is -3/2 times x minus x1, which is 2. Okay, so I'm going to start simplifying. Y plus 1. Why is it not working out very well for me? There we go. Is equal to -3/2x And then negative times negative is going to be positive. And 3 over 2 times 2, well, the 2's cancel, and I just get 3. If you don't remember how to do that, right, negative 3, as a side note, over 2 times negative 2, and if I make that a fraction, it becomes over 1. And I multiply straight across, so I get positive 6 over 2, which is 3. Okay, and then subtract 1. So y is equal to negative 3 over 2x plus 2. And there it is. Sound good? Yeah? Okay. So there isn't a U-try for this one. So I'm going to go ahead and clear this and scroll down. So for example 8, I'm just going to go ahead and show you. So what I want you to do is with your graphing calculator, I want you to go ahead and graph y equals x plus 1 and y equals negative x plus 3. You should have learned how to do that in Pre-Calc, in Algebra 2, but I'll go through the steps here in a second for how to do that. So go ahead and graph both of those in the same window, and then go ahead and hit play when you're ready. Okay, so we'll pull up our graphing calculator now. So I'm going to go through the steps on how do you graph these two. So you're going to go to this y equals, and then make sure everything here is cleared out. So you just want to hit clear if there's stuff written here, okay? So we're going to type in our first equation, which is y equals x plus 1. So here's my x right next to alpha, x plus 1. Then I'm going to hit the down arrow, and I'm going to go, the second equation is negative x plus 3. And then in the top right corner, I'm going to go ahead and hit graph. Okay, so in example 8, if you're reading along with your packet, it says, we graphed these in the same viewing window, done. The lines are supposed to be perpendicular because the slope of one is 1 and the slope of the other one is negative 1, which are opposite reciprocals of each other. Do they appear to be perpendicular on display? So just looking at this right now, does it appear to be perpendicular? And hopefully you see, no, these two lines do not, they don't look like they cross at 90 degrees at all, right? It looks like it's definitely not 90, just by looking at it, you can tell it's not 90 degrees. And so the reason that this is not 90 degrees, or why it doesn't look like it's 90 degrees, even though it technically is because of the scales of your x and y axis. So your x and y axis automatically default to go from negative 10 to 10, and then negative 10 to 10. However, the width of your screen is a lot more than the height of your screen. So the distance in between these guys on the y-axis are a lot smaller than the distance on the x-axis. So what we can do to fix that is if we go zoom, and then we go number 5, which is square, z square. So if you hit 5, what that does is it adjusts the window so that every single tick mark is equally spaced on both the x-axis and the y-axis. And so now the question is, does it look like it's perpendicular? And yes, this looks much better. Looks like it's 90 degrees. Okay. So once you get that square window, then they actually do look like 90 degrees. So just some sort of note to yourself on that for example 8. I would say, or when it says, do they appear to be perpendicular? I would say not with the standard window, which is what we had earlier. So I would say not with the standard window because the screen is rectangular. Okay, but with the square window, they do. So that's what I would write. And if you need me to repeat that, you can rewind the video and watch it. So hopefully we're good there. We just have one problem left. It does have multiple parts, but we're almost done. So I'm going to go ahead and get rid of this calculator. We don't need it. And then we're going to move on to modeling. Okay. So here it says, this graph shows that the cost of the average retail prescription drug has been rising steadily since 1991. We know that, right? Prescription drug prices are way too high, but they have been continuing to go up every year. So here we have the graph for it. So part A says, according to the graph, what is the y-intercept? So when you look at the graph, where does this graph cross the y-axis? Well, it crosses it right here at 0, 24. So the y-intercept is 0, 24. Then it says, describe what this represents in the situation. Well, what is year 0, right? The x-axis is labeled years after 1991. So year 0 is 0 years after 1991. So that's 1991, right? So that tells me, and then the y-axis is the cost in dollars. So this tells me that in 1991, it cost $24 for an average prescription drug. Because this is a word problem, you're going to want to actually write out a sentence answer. And I'll try to do this. So the cost of the average come on now prescription and then I'm going to include the actual details now. In 1991, and then was $24. So the only thing is, when we're talking about word problems or we're talking about real world situations, you always want to make sure that your answer is a full, complete sentence. Okay, so in 1991, the average cost was $24. So you'll have to look at your picture still as we do this. I just can't show both. So part B says, use the coordinates of the 2 points shown, which are 0, 24 and 738, to compute the slope. What does this mean about the average cost? So let's do that slope first. So my y2, let's say, is 38. Minus my y1 is 24. Over my x2 is 7. My x1 is 0. Which 38 minus 24 is 14. And I get 14 over 7, which is 2. So this tells me, and so that's the slope too. What does that mean about the cost of the average retail prescription? It tells me that the cost is increasing $2 a year, right? Every year it's $2 higher. The cost is increasing we'll totally have to watch this at double speed. By $2 per year. Okay. Part C, write the linear equation that models this. So write the equation. Well, I know what the slope is, and I know what the y-intercept is, so this should be really quick. So y equals, come on now, my slope, which is 2x, and then my y-intercept, which is 24. So there's the equation. And then part D says, use the model from part C to predict the cost of the average drug in 2010. So I'm actually going to clear this and move down so we can have more room. But I'm going to rewrite this. So this was y equals 2x plus 24. Okay, so 2010. Well, I know that 0, when x is 0, that represents the year 1991. Come on now. Okay, so 1991 is 0. So how many years from 1991 to 2010? And if you're using your quick math, it's, wow, not 20, 19. So when x is 19, that represents 2010. So because of that, all I have to do is plug in 19 and I'm good to go. So y is equal to 2 times 19 plus 24. So 2 times 19 is 38 plus 24. And I get 62. So again, because this is a real world problem and you need a sentence answer. So we can say in 2010, comma, the cost will be $62. Which is like crazy expensive. Okay, so hopefully that makes sense. Again, if you need help on anything in this video, please make sure that you reach out either during office hours or during another time, and we can schedule one-on-one time and we can go over stuff. Otherwise, we're good to go, and I'll see you next time.